test, test. Oh, hey, Christian. Hello.
Hey.
Jacob. Hey, how's it going?
I'm good. How are you, Brian?
Pretty good. I realize I'm in whiteout mode again. I don't know what to do about this. I got these new lamps, like these Chinese sort of, it's like a hanging plant kind of thing.
Yeah.
But they totally wash out my very antiquated camera. So.
Yeah. What's the lighting like if you just turn them off? Is it too dark?
It gets pretty dark. That's the thing. I guess that's not bad for you. Like that looks way better on the camera, huh?
Yeah. From my perspective, this looks good. You look less like Casper the Ghost.
Right? No, but now I'm like, I can't believe I used to work in this. I feel like I'm in a dungeon.
It looks really bright in there still.
Yeah, it's because it's basically this camera. It's like a 2002 webcam, so I just need a new one.
You might want to see if you can like point it down a little bit too.
Oh, really?
Yeah.
Okay.
Yeah. Yeah. Perfect.
So how's it going, man?
Going good. Just, wallowing away in my sorrow as always.
In your sorrows? That's not good. How's is it Finca?
Findco.
Yeah, how's Finca going?
So I launched another product it was sometime in February, by the way, called The Sample.
Okay.
So it's like Findco essays, but instead of recommending essays, it recommends newsletter editions. So basically I set up an inbound mail server and then signed up for like 1 billion different newsletters. And so whenever they send me an email, it gets put in the database, and then I forward issues to people using an algorithm.
So it's selecting newsletters that you think they might be interested in.
Yes.
Cool.
So that's going, and I've put ad money into it.
Oh, really?
So I've spent. I actually haven't been tracking it super closely, but I've spent several hundred at least.
How long have you been doing the ads for?
Couple weeks. I've been experimenting with like taking out ads in other newsletters, but it's very hit and miss. And so I actually just started a Facebook lead ad, so we'll see how that works. But in general, the metrics for the newsletter are quite good. Like open rate is 60%, and click through rate is like 20 something. And yeah, so yeah, so far it's looking good, and I think this will be a viable business, hopefully.
Oh, right on, man! Congratulations, that's cool. Looks
Hi, Jeremy.
like, yeah, Jeremy just joined us. Sweet. Hey, man, how's it going? I think you're muted.
Yeah, I don't see the muted thing, but I also don't hear any noise from you either.
From me, sorry?
Oh, no, from Jeremy.
No, from Jeremy.
Hey, now? Sorry about that.
Now?
Wait, I think I heard you.
How about now?
There we go.
Okay.
It's
Yep.
kind of quiet, though.
Quiet. All right, let me check something.
Sweet.
Testing, 1, 2, 3.
Seems pretty good.
Cool.
It's good, is it? All right.
Yeah.
Roll with that.
Yeah.
Hey, Christian, whereabouts are you? It's looks daylight there. Oh, I can't hear you now.
Huh, are we having something weird going on with the audio? This is frustrating.
Hey,
There we go. Cool.
I'm located in Vancouver, so it's 4 p.m. now.
That's good. I'm the only one where it's 11 p.m.
Yeah, man, thanks so much for joining us this late in the day.
I know, it's cool. It's kind of nice, actually. Like, yeah, I don't know. Like, normally, like when you have a presentation or whatever early in the day, you're like stressing about it more in a way. But like when you know you have the whole day to like get prepared, I think it's good.
Right. It's sort of like the last thing to check off the list.
Yeah. And don't worry, we'll be sure to have this over in under 3 hours so you can get to that.
Well, we might have a lot of questions. Crux is super interesting. I
prepared my list of questions already.
You right on. I think, Jacob, you're the only one in our group who's officially using it. Is that right?
Perhaps.
Say it again.
I think so. I think Tori said he at least tried it out a bit, right?
Oh, cool. Hey, Sean. How's it going?
Hey, folks. Good.
Welcome. Glad you can make it.
It's an interesting topic.
Yeah, it is.
Take time out of my workday for this.
Awesome. Yeah, we had to have it a little earlier than normal. Jeremy's London time. So it's good of him to make some time out of his busy schedule for us.
Yes, especially this late in the day.
Yeah.
Thank you, Jeremy.
That's
As an
right.
ex-Brit, I totally appreciate this.
I slept in early, especially, so it's all good. I slept in late, rather.
Is everyone able to hear Jeremy okay?
I hope so.
Yeah.
It might just be me. I'm like, maybe I'm a
Oh,
little...
wait, maybe it was off. Huh. Is it better now?
It's a little quiet, but we can hear
I can
you.
bump it. I can.
Okay, cool. I'll put my
There you
headphones.
go. That's an extra
Actually,
22%.
to me, it's not late at all. To me, it's really, really early. I mean, 8 a.m.
Where are you?
I'm in Seoul, in South Korea.
Oh, no.
I just woke up for this presentation.
Good morning.
I am, I guess, also using Crux because I just heard someone say that only Jacob was using it officially. I'm also using it, but I mean, it's not in production yet, but I intend to put it into production.
Cool. Is that like a thing you're just working on your own or for work or what?
Yeah, it's a side project of mine, but I hope someday we'll make money. I'm making an application for learning Korean. I've been working on it for quite a while now, and Crux was quite recently dropped in as a replacement for Data Hike and Data Scripts and Datomic. I'll use them all, and now I started using Crux, and I really like it so far.
Nice.
How do you feel that it compares to Datomic?
Well, it's really flexible, I guess. I mean, both use Datalog, and but I mean, because it's no schema, I was expecting it to, yeah, I don't know, cause some trouble, but it was surprisingly easy to get most things going. Yeah. And for the rest, yeah, I don't really have any like metrics or other opinions about the differences.
Yeah, cool.
Brian, I was just checking if I could share my slides or whatever. Can you set me as a host or enable participant sharing?
Okay, you're the host.
Well,
Cool.
Thank you.
Hopefully you won't have to let people in. I have it. I forgot
I was
to turn
gonna
off
say
the...
you might want to retain yourself as a host also, because then also like if someone's mic is on and you need to mute it or something, you can do stuff like that.
Yeah, I'll make sure you're also a host. Make host. Oh, you can only have one host? Oh, you're right. Yeah, you don't always have multiple hosts in Scene.
Is there like a co-host or something?
Yeah, I
That
think you have
was
to pay
the-
extra for that.
Yeah, that was the thing we were talking about earlier, Jacob.
Brian,
Well-
I'll make you host again, but maybe I'll just set it so participants can share. That'll probably be best. Right?
Yeah, we can
Okay.
just enable screen sharing. That should be fine.
Where do I do that at?
It's under security.
I'm just making you the host again. I've already done it.
All right,
Oh,
perfect.
cool, thank you. I always forget. Oh, there it is, security. I don't see that, Jacob.
Well, maybe it's already.
Oh no,
checked
it's
now.
already checked. Yeah, okay.
Yeah.
So we should be good then. Can you share your screen? Yeah, there we go. Sweet.
Alright.
Cool. Do you have a big box in front of it, or is it
Yep.
It's a black box.
a black box? Okay. Compositing, nice. All right. Should we give it another minute just to wait for stragglers? How do you normally run it?
So we can kind of do like we talked about. You know, I'll kind of let you feel it out, and maybe we can do a quick go around to see kind of who all is here, and if you want to gauge like any kind of specialization of the presentation that you might want to do based on the participants. That seems like a good idea. So
Okay.
I'll just, yeah.
Yeah. So I mean, I see some familiar names in the thing, but maybe if anyone wants to, like, I don't know, self-declare that they use Crux or have tried Crux, that could be interesting. If that turns out to be a lot of people, then that's probably a good thing. So, and maybe just say what you're doing. So, like Jacob, I know you're doing it, or you're using it. If you want to say something about it.
Yeah, sure. Yeah, so I started using Crux, let's see, about last April or May. I've been doing a startup on my own for a little over 2 years now. I used Datomic for about a year, switched to Firebase for a few months, and then settled on Crux, and it's the database of my dreams, basically. So I love Crux. So I'm very excited for this.
Cool. And Barak, you said something before people will have joined, but you've woken up early because you're very excited about Crux.
Yeah, I guess. So I started working on a Korean learning app around a year ago. I've mostly spent my time on Clojure scripts because I want it to be nice and interactive. But yeah, I tried Datomic Cloud, or yeah, that's called Datomic Cloud, and I tried DataHike, and they were very similar. But I thought I'd give Crux a go, and it's been quite delightful to use. It was not too hard to adjust to my system. I had some inspiration from Jacob's system for how to create my transactions, and like I recently found a big data set which I put into Crux with it's like a Korean dictionary with lots of example data, and since it's an API, it's not exactly nicely schema data, but putting it into Crux was kind of a breeze. And then the best part is I tried to make a search, like an autocomplete search. I just started doing that a couple of days ago, and being able to just combine with the graph way on that data, even though it's not structured yet, and I still got it to work really well, especially with the new syntax you guys have for the EQL project stuff, renaming the properties as you pull them. It's really awesome, and I think I can, maybe soon sometime share in your channels what I built, and yeah, it's been pretty great.
Awesome. It was on Zulip. We were exchanging messages, right?
Yeah, I ran into some issues with building, or with some of the with project, I think, but that was solved, and that was what we talked about earlier, and a little bit about my app. Yeah.
Cool. Thanks. I know Stephen, who is working with Jux at the moment, is on the line as well. Maybe Stephen, you want to say about what you've been doing?
Yeah, I can do. So I came to Crux. I actually think that there are probably quite a few of Jeremy's slides that speak to how I ended up with Crux. I was actually completely disinterested by Bitemporality. I was using Neo4j to try to construct a digital library of largely ancient Pali literature, so about 2,500 years or 3,000 years worth of literature. And Neo4j worked, but it wasn't ideal. And so I kind of came to Crux by accident. I was looking at other Jux libraries and noticed that, hey, there seems to be a graph database in here amongst the other things that Jux built. It's actually suited my needs really well. So my case is probably the most boring of anyone who's using Crux. I'm not doing unstructured data or anything fancy with Datalog. I'm essentially replacing Postgres effectively. My data is graph data, so I can't use Postgres for it, which is why I was using Neo4j. But Crux adds quite a few things to that that Jeremy will probably talk about much more lucidly than I can. But that's kind of where I came from.
Cool. Thanks. Did anyone else want to just throw out any anecdotes? Otherwise, I'll kick off. Please feel free. All right.
Yes, I'll mention, or I have one thing. And the excitement of the moment, I forgot to mention I also built a web framework that uses Crux at the heart of it, BIF. So another reason why I think Crux is awesome.
Yeah, and as a small note, I failed to mention that I'm using Fulcro on the front end, and that those two match really well together.
Yeah, I saw someone else post in the Fulcro channel that they built like a Crux RAD thing. So that's my weekend.
Yeah, I started out with a RAD, but I haven't checked it out yet. It's really cool if it works with a RAD.
Yeah, cool. All right, well, I'll kick off then. So hello. Oh, sorry. Who was that? I'm not sure. Anyway, okay. So yeah, my name's Jeremy. If you've not met me before, yeah, I've been with Jux for 2 years now. I was at IBM before that, and really like what drew me to Clojure and the world of Datalog was just a real passion for knowledge management. So it's been really fascinating this last like 18 months watching Rome research and Athens and all these other sort of Rome clones crop up, because that's exactly where my head has been at for the whole time. I spent a lot of time playing with data script running against logs stored in Firebase, that sort of thing. Yeah, since joining Jux, my attention's completely switched to looking after Crux. So that's the open source community, our enterprise clients, and just generally making sure that the product is heading in the right direction. And it's a team effort, really. Like, there's quite a few people involved and a lot of stakeholders. But yeah, I just have oversight of most things to do with Crux. So I'm going to go into as much technical detail as I'm comfortable with this evening. But yeah, feel free to push the limits of my knowledge and ask Q&A throughout. Like, if I'm saying something that doesn't seem right, or do you want to probe further, please interrupt me, because it's quite late here. It's like 11 p.m. And I think as it goes on, my coherence will diminish, and if we leave all the Q&A to the end, it'll be bad for everyone. So questions throughout, please. So I have a few slides. I think slides can be effective, although I've also got a bit of a REPL demo too. On the list of things to discuss, I want to just cover off bitemporality first. I think it's like it's a sort of scary sounding feature. Not everyone's interested in it, and I just want to cover that early so that we can talk about the more interesting things, which I think is more relevant to everyone here, which is the data log, the architecture, how it's put together. And then I want to do a bit of a deep dive into the query engine. So we've not talked about it too much or written about it really, but I wanted to share some sort of extra details about how that works and why it works the way it does. And then I've been sort of aware of all the other data log things that are out there. So I know we've got Christian on the line and Paula as well. So Data Hike and Sami, DataScript, and like all these other technologies, like how do they really compare to Crux? Like what are the goals of these different projects? Because Crux was born for a fairly specific use case. It just happens to be generally applicable, but we have our own sort of vision and roadmap, which we'll cover as well. So I'll pause there for a second. Is there anything that people don't see on there that they think, oh, this is rubbish? I didn't come here to see this. Anything else you want to see?
Jeremy, I was just so you might have mentioned it, but you said it. What was the use case, the specialized use case that you had originally built it for?
So it's essentially in a financial services domain, you quite often have like trading desks and trading floors, and you have like back office teams who do like risk management to make sure that at the end of the day, like those systems, like all the trades that are being carried out, are not overexposing the bank or whatever the organization is. And so there's this problem where you've got trades which are happening globally, like in different regions, and then you need to be able to run like a temporal query to say, what was our risk exposure as of 5 p.m. And then as like your knowledge about the different trades evolves, or like people realize that there was mistakes, you sort of need to update that, and then you need to have a temporal history of those changes for the auditors to be happy. So it's like the word bitemporality means a lot to like a fairly niche audience in like insurance and finance, wherever you have audit, basically.
Cool. Were you able to also, so in that specific application, were you able to capture also, because trades are usually fast, especially in a professional finance shop, like, are you able to capture the reason also, or?
So, I mean, I guess it's worth qualifying, like that particular system was like a precursor to Crux. So Crux is actually built sort of following that particular engagement, but we are working with other financial organizations now to roll this out in a similar capacity.
Cool.
But in general, like you're not going to be using this for like algorithmic trading or anything like that. It's much right. Larger orders, and I'm not a finance person. But.
Yeah, I guess the source of my question was really, I built I have a background in knowledge representation and reasoning, and I used that for tax. And it was really great for tax because like the US tax code is essentially NP complete, right? Like you can really not represent it in a computer. And it came out really clean using knowledge representation. And so it's interesting that, you know, you mentioned this as a knowledge platform, and yeah.
Yeah, that is interesting. I think there's lots of like applications that Crux is good for, like beyond this, like this niche where it was born. But certainly that niche like drove a lot of performance requirements. You know, we tried all the different technologies that were available. You know, the ones you can think of, Oracle as well, and none of them would perform in the way that we needed to. So we had to hand roll these indexes on top of RocksDB to get the performance. So anyway, that's that, and I will sort of cover a little bit more as well on that topic. Is there anything else? All right, maybe we can come back to the US tax code at the end. I'm aware it's complicated. Cool. So I want to start with this example, which you may be thinking that date is like 2 years out of date. Well, actually, we're almost at the 2-year anniversary of Crux's first release, the public release. So that's our epoch. Anyway, this example I think is fairly accessible. So what it's showing is, you know, you're on an e-commerce website. You're going to check out. You want to enter promotion code, and the checkout code, you know, in addition to all the other things like tax calculations, whatever it has to calculate, it needs to look up the code that you've entered in the box and to see whether it's actually valid for this, you know, for these items. Like, you know, some codes are like specific to a particular product or a catalog, group of catalogs. And then, yeah, like, is it actually valid within this window? So you're recording times for these sorts of systems like everywhere. And in particular, you have this valid from, valid to. So this is kind of like the most accessible example I can think of, at least, to explain bitemporality to someone that doesn't work in finance. But you can see that, you know, like the day before the promotion wants to go live, you sort of want to create the promotion. Then you say, you know, it's going to be valid from tomorrow at 9 a.m. And then as the promotion is running, you're generating these codes, and then the codes themselves have a validity period for like a month, say. And, you know, this is a fine way to model it. But if you're using like Postgres or whatever, like the database really isn't giving you anything. Like, you're going to have to write some really gnarly SQL. I mean, even if you write this in like a normal Datalog database, you're going to be writing some, you know, quite a bit of extra code, and then not getting the performance necessarily that you'd expect, just because you have this sort of pervasive complexity of handling these valid from and valid to in certain domains. I mean, clearly a lot of people don't have these problems, but for those that do, they'll recognize it quite quickly. So Crux is our sort of answer to this issue. And the best way to think about bitemporality, I think, is like, it's just a layer on top of immutability. It's saying, what if we had a virtual timeline and you model where things go in that timeline, and that happens to sit on like this ever accreting transaction time. So in this diagram, we have audit history as the x-axis, and then validity, you know, the valid time history is the function of that. And so you can never insert into the future of transaction time, but you can insert into the past or the future of valid time. And reasons why you might want to do that, it can be, you know, very domain specific, or they can be, you know, just sort of non-functional, like, you know, oh, I need to migrate my database from like here to here, and I don't want to lose all of my point in time queries. So this is one way to think about it. Another sort of place that bitemporality was born in like the 90s was people thinking about the best way to like represent knowledge at a more fundamental level, and especially where you've got like, you know, forensic investigations or something. You really want to answer these questions. You know, what did the world look like as of, you know, 5 p.m. yesterday? What did this person know? So sort of having these deep questions about time sort of are quite relevant in various domains. But what we, I think, generally care about in this closure world of Datalog is, you know, the state of the database. We just want to be able to reason, you know, from one point to another, like what was the consistent change that happened? You know, what was the atomic change in the system? So I mentioned sort of inserting to the past. So you could think of that as like backfill, but you also have corrections. So yeah, if you realize something was erroneous, you can just override it. What that actually means in your application, so for your own sort of judgment on how to model it. I mentioned this financial use case where we had traders in Asia Pacific and the US and Europe, and each of these systems were sort of upstream to what was being built, and we needed to somehow sort the validity to understand for a given point in valid time, what was actually visible, like what were the active trades, and so that's the other sort of key use case. Well, yeah, well, so this diagram, again, another sort of illustration where you have transaction time is always monotonic, but valid time, it can be into the past or the future. So here's some timestamps that says, well, I can by default always insert into now, like in the same way that transaction time is always now. But if you don't specify valid time, it's always now. But if you want to make a correction to the past or insert into the past, a retroactive insertion, you say valid time is in the past, or indeed, then you just carry on and say it's now again. So to be honest, it's usually quite rare that you want to edit the past or the future, but when you do, it's quite invaluable. So this is the last thing I want to say about bitemporality, and we can almost sort of park it for the rest of the evening unless people want to talk about it. But the main thing to get across is that it's for free. It's at the foundation. It's like below the data, but it's always optional. So you don't really have to worry about it. But when you do need it, it's of course there, which is good. So I'll pause. Anyone want to probe any further on that? Okay. I think there's a raise hand feature. I don't know if I'll be able to observe it. Anyway, so the other reason we're all gathered is to talk about Datalog, which is, of course, like, this tremendous, beautiful thing, which, the Cognitect team did a fantastic job to sort of imagine or reimagine Datalog in terms of Eden. And, I think everyone's sort of gathered here, I guess, because we all recognize the sort of beauty and simplicity in this model. And there are a few things that sort of unify this regardless of what actual engine you're talking about. It's the fact that you have these indexes backing it, so you can, doesn't matter which way you traverse the relationship, so it's always quote unquote fast. You've got logic variables, which allow you to do some really wacky things with custom predicates. And of course, rules, which are in a way like the essence of Datalog, like they are the abstraction that Datalog offers. And we've been doing some authorization work on top of Crux recently, and rules are just tremendously useful for doing that kind of thing. For anyone who's not familiar with Datalog, and I'd be amazed if anyone, just a quick show of hands, I guess, is there anyone on this call that isn't already sort of, that hasn't tried one of these Datalog databases, whether that's DataScript or Datomic or even Crux? I'm guessing not. Okay, well, it'd be interesting to know if there is, but at a high level, it's pattern matching. And the kind of pattern matching we're interested in with Crux is maybe sort of one level up as well. So you've got sort of pattern matching within the query, but then how the query actually can find patterns in the database is like another level. So what do we do differently to that sort of standard Eden Datalog? Well, the first thing is we don't really talk in terms of datums, and we'll come on to why in a bit, but essentially we talk in terms of documents. So you're always working with this sort of atomic version of an entity, and then the documents set in a timeline. But the entity is specified by this crux.db ID, and the way you traverse the relationships is completely dynamic. So you don't have to declare up front that this model name is of type string or whatever, or that this pilot is of type reference. It's just, oh, there's a keyword value here, and at runtime the engine understands that this thing is the same as this and allows you to traverse it if you write your query in the right way. And then we also split sets and vectors into cardinality many EAV. So for a single document like this document, this bottom document, it'll have like 1, 2, 3, 4 triples coming out of it. So that's how the indexing works. There's also some other things we have slightly different, like we have in rules, you can hint what are the input or the bound variables going into the rule. And that makes certain types of rules like way faster to execute. So that's quite a powerful feature. And you've got like support for literals and things. But essentially, it's the same thing as you might have seen with other Datalog engines. So now I want to talk about the architecture, and I'm sure everyone's spent a bit of time looking at this, but you've definitely not spent as long looking at this as I have, because this is like the, I don't know, let's say the 15th edition of this diagram that I've put together, and it's probably overdue for a refresh, or it definitely is. But the key thing it tries to get across is that the transaction log and the document store are like these central shared resources, and everything in Crux sort of goes through those. And that necessarily means that the indexes are separate to the log and the documents, which, yeah, that means everything is inherently asynchronous. So when you submit a transaction to Crux, you're sort of getting a commit back from the document store and the transaction log to say, yep, that's been written, but you are not able to query that until you wait for the transaction to be indexed at the node that you're actually looking at. So this, unlike other databases, sort of, it's decoupled or unbundled the architecture. And it has a few advantages. It does have some level of disadvantage, which we'll come to. But the main thing is that you can replay this like infinitely. Like you could experiment with the contents of the orange box, what your Crux node is actually doing, sort of as much as you like, and you can always be confident you can rebuild from the source, the golden store of data. And the actual transactions you put, you run through Crux are put, delete, match, and evict. And we also have transaction functions, which are essentially custom ways of compiling down to those 4 primitives. And I guess the most interesting thing is, you're able to put things into the document store. And that is sort of set like a semi-mutable place, because occasionally you'll want to evict, and that eviction actually places a tombstone over the original document. But the transaction log is like truly immutable. And what goes on the transaction log is like hashes. So it never actually has any of your actual data. And that's how the eviction works. And then once the node is, like once you start a node, you point it at a transaction log on a document store, and it will begin to index the data locally inside of like a RocksDB or LMDB, or just in memory. And indeed, this whole thing can be in memory. Which brings me on to the next point, which is that like there's a lot of ways to configure Crux. It's kind of been built as a bit of a playground, for better or for worse, where you can build like a system to meet your various non-functional requirements, whether that's like during testing, you don't want to have to spin up like a Kafka cluster, or it's actually in production, you want like the fastest or the lowest latency possible, or like the fastest throughput, or like the highest query speed, because we recommend RocksDB throughout all these, for instance, but actually LMDB is faster for queries. So if you really do have a query intensive workload, then check out LMDB. But this sort of defines a spectrum of the various ways to run Crux. So at the top, we've got like, let's just start an in-memory node. This is the data script, like, it's just a hash map sort of thing, or like an in-memory data structure. It's slightly more heavyweight than data script, but it's still very little overhead, really. And we'll see that in a minute in a demo. Then we have this other mode, which is like, I just want to run it as like a SQLite thing. So it's called that standalone. Then we've got using JDBC store. So JDBC based databases, whether it's like Postgres or whatever, most companies have some way they can provision or procure those JDBC databases already. So it's like a very cheap way to start using Crux, especially as well if you're going to use like a cloud service, AWS Aurora or Heroku or whatever. You can connect it to a Postgres store very simply, and then you're still running your RocksDB locally in your nodes. And then when you eventually do have like this, big sort of scale problem or throughput problem, then of course we have the Kafka mode or topology, which is really where Crux was born from. It was like, oh, let's just plug Kafka into RocksDB and see what happens. And like everything else has sort of evolved from that. And you notice actually, there's 3 components: the doc store or txlog doc store and index store. With Kafka, of course, Kafka is not like a random access key value store. So we actually have to sort of cache the local, like a full local replica of the doc topic in Kafka, and we call that a local doc store. And then any of these things can be embedded inside your application or made available over HTTP. So there's just a huge amount of flexibility, and that is, as I say, like a good thing in many ways, because I think it inspires people who have very complex requirements to at least give it a go. But in terms of like how we as a team like then ship artifacts, like do we really want to ship like 60 different packaged jars or Uber jars or something, or Docker images? These are deep questions for us. Or should we just have like a big kitchen sink thing? So that could be interesting to debate. But what I want to do now is to take you through the same architecture, but like from first principles. So like we have this idea of a transaction log. What does that give us? Well, it gives us this sort of single writer, like the highest throughput possible sequence of transactions. And in theory, actually, Kafka is not even like the most fastest possible way to sequence transactions. Like you could even use something like faster than Kafka potentially, although Kafka is a very, very good way of doing it. But the key thing is that Kafka provides a timestamp. So when you write things into Kafka, you can say, this is the transaction time. And by using that as the definition of consistency, it basically means you don't have to have any nodes that are online. You could just we have a way to use Crux, another topology called an ingest client, and you can just fire transactions into Crux, put data into Crux without actually indexing it. So you can be sure that stuff is going there, being committed to the database, but it's not visible for queries. You can't query it. And this has useful applications where like write loads are spiky and that sort of thing, and applications can tolerate a bit of latency or staleness. And that's really the heart of ACID. The next level is the document store. So we've already discussed this is like a way to abstract away from putting all the data into the transaction log, which would be that's the easy option. But the doc store is this thing which is abstracted via hashes. And has this mutability, as I said, but it also has this nice property that documents, aside from being like keyword maps, like the top level keys need to be Clojure keywords, or we have a JSON API and they can just be strings. Like you can pretty much do anything else you want, with the other exception that you need an explicit ID, and there are like some supported types. But this is like a very, very generic model. And it's all made possible thanks to Nippy, which does a magical job sort of serializing just about anything you throw at it. And then when you're indexing these documents, you might represent these different values in different ways. But fundamentally, you can always get back exactly what you put in. If you don't have to worry about modeling like an arbitrarily deep map structure as like triples in order to store it, or you don't have to serialize it into something else. You can just store it in there. And again, this is ACID. So what actually happens is when you submit a transaction to Crux, it writes everything to the doc store. And then once the docs are all written, it writes the commit into the transaction log. And so, these 2 layers enable then a third layer, which is this, n number of nodes. So horizontally scalable cluster of Crux nodes, all at their own point in consumption of those transactions. So that we don't have any communication between the nodes aside from, they're all reading from the same log, they're all submitting to the same log. So that's quite powerful because it means, you can have complete isolation between workloads, and you can do things like, I'm going to have these nodes with RocksDB, these ones with LMDB, or like these ones at version, 1.50, these ones at 1.51, and do this sort of rolling upgrade, which is another valuable property of having this replay basis for the system, as opposed to, we've got to do like an index to index migration, which is always a much trickier thing to get right. So then above the nodes, we have these things called the index store, and an index store is like basically where all the state goes in the node. There's nothing in the node. There's no like files written to disk. There's no, I don't know where else the state would go, but like the node doesn't have to register itself with a cluster. It's like if you have this index store stored in like RocksDB, you just copy that RocksDB folder and then you paste it over here, and you've spun up what looks to be like an exact replica of that node. And that's actually how we manage sort of not having to replay from day zero of the transaction log. If you want to scale horizontally, you can just spin up new nodes based on essentially just copying the indexes because they are independent. So the key property for an index store is we rely on like a single key value space. So RocksDB and LMDB, for instance, have this property where you can essentially have like an arbitrarily large key space, and it's all sorted. And we then in the Crux layer then partition that to do various sort of Crux indexes. Now things like RocksDB do actually have like an abstraction for this, which is column families, which can partition the database, but then like LMDB doesn't. So anyway, we sort of do it at the simplest possible level, which is like if you have a sorted key value store, sorted. That's good. And like a few months ago, I was experimenting with Redis because it has a Z range by Lex function, which allows you to store like a sorted key space as well. And like you can use this to run a Crux node as well if you want. Or there's some caveats to that. And then the important operation on this is prefix seek. So that's the Rocks term for it. But if you have like the first few bits of a key, you can jump straight to that key and then iterate through the subsequent keys. And that capability is like, that iteration is like a very foundational part of how the query engine works. So on top of this index store, we have the bitemporal indexes. As I said, like time is at the foundation of Crux. So before you even get to thinking about like queries, we just want to store documents in their raw form at points in time. So we take like a content hash of a document at like a version, and then we associate that with a point in transaction time and valid time. So regardless, even if you're not thinking consciously about bitemporality, we're always recording this index. And what this allows you to do is to always go back to the past, because these are stored. So that we actually have two different bitemporal indices. Like one is like sorted list of, it's like sorted by content hash, valid time, then transaction time. And then they're sort of reversed in order to do this. John did a good bit on this on the Reclosure talk in December. And then we have another index, which is like this Morton index, which is a fractal Z order curve, which allows you to jump straight to anywhere in the two-dimensional plane, like within, say, like 3 seeks or something. So it's a very efficient way to represent temporality. And the important capability here is that like you can do ad hoc queries of the past. You don't have to like scan through or filter through like an EAVT index in order to figure out what the past was. It's like you resolve the content hash, and then you look up that content hash in the triple index. So once you've sort of resolved these, what version of a document am I looking at for a given temporal coordinate, which is usually now, show me all the triples that are valid. So the triple index has some parallels or things roughly familiar, AEV, AVE. We have like something called CAV as well. And we do some interesting data structures to make that more compressible. And sometimes we go back to the document store as well. So we have like a document store cache. But aside from these triple indexes, we also store statistics about the indexes. So we store like the attribute cardinality, and actually there's a pull request open right now to add hyperlog log to store the selectivity of different attributes, so we can use that to inform the query planner. Which brings me on to the next bit, which is the query engine. So we built a brand new query engine in Clojure, and some sort of fairly low-level Java as well to make it fast, which uses this sort of tuple at a time concept to execute queries, and that actually requires these statistics. So the reason why we're capturing statistics is to make the queries as fast as possible, and then we cache the query plans, and we'll come on to what makes the query engine tick shortly. And then on the layer top of that, we have Datalog queries. So I've already been through sort of the syntax differences a little bit, but we actually have some extra APIs. So we have the laziness of the query engine exposed to the Datalog user, so the end user, via like an OpenQ API, which returns an iterator seek, and then or returns an iterator, then a Java iterator, and you can call iterator seek, and then like take 5 from the query, and it will lazily just return like 5 results, and it won't finish executing the rest of this, horrifically slow running query. So that's quite powerful and allows you to mix Datalog and Clojure to sort of run your own like graph search algorithms. And then we've got subqueries, which are important aggregations. And we added these fairly recently, actually, but they were necessary for us to write TPCH benchmarking tests, like to translate from SQL into Datalog without touching Clojure. You want to represent or model the entire SQL, or that subset of SQL at least, using nothing but the Datalog. There's one other point here, which is declarative construction of where clauses. So what do I mean by that? It's this idea that the clauses you specify in the where section of your query, they're essentially ignored. That ordering is ignored by Crux because if it wasn't to ignore it, it essentially puts the role of the query planner on the user. And it's a bit of a philosophical stance, but we think that really a database should have a query planner which takes that load off of the user. And even if it's not always perfect, like you can usually work around the plans it generates, and you're able to observe those through debug logs. But anyway, there's an argument which is like it's a more declarative Datalog as well. So that's the 8 layers, and of course there's layers on top of that. I haven't gotten that far. Maybe I'll make this even taller stack at some point. But you have the ability to benefit from all the capabilities via HTTP, and we have a client API which wraps that, which feels very much like you've got like the in-memory Crux node as well. We added a Lucene module a few months back, which has these full text search predicates. And lastly, we have the Sql module, which uses Calcite, Apache Calcite, to compile. It's like SQL 92 sort of standard. It's not like all SQL features ever, but it's a pretty good coverage, and like Apache Hive and other big users use it. What's the word? I forget, Dremio. That's it. Dremio use it, and you can connect it to Metabase. But what's interesting is that we implemented it by compiling the SQL into Datalog, and that wouldn't have been possible without this query planner, because it would have meant the Datalog we're compiling into would have had to be optimized by us, or like at the level of the SQL, the Crux SQL module. So by having the query planner below, we sort of saved us having to invent like another layer. So that's good. And of course, there's other modules and things to talk about. That brings me on to the next topic, which is graph querying. But I'll just pause there because I need some water. And does anyone want to offer any opinions, or whether that illustration was at all helpful in sort of getting your head around Crux?
I have a comment. I had no idea that where clause ordering was ignored. And all these months, I've been painstakingly deciding what order to put my triples in to make sure I have fast queries. Anyway, so I feel like I've been enlightened.
Okay, wow. Okay, sorry. We should probably put that higher in the docs then. Okay.
Am I right that
Okay.
in Datomic, the clauses do kind of matter, the order of the clauses?
They absolutely do, yes.
Okay, thanks.
Yes, we got that at work. We had some real issues with that.
Yeah, and the problem with that approach is that not only do you have to figure out the first time, but then as your database population evolves and like the shapes of the data in the database evolve, like you're always going to have to keep sanity checking or revisit the question of is the order correct, and it just gets hard to reason about at a certain scale.
Jeremy?
Hey, Christian.
Hey, can you maybe spend a few words and explain how you use these mutable indices in a way that makes them persistent, like RocksDB and LMDB?
Well, the short answer is we never delete any keys, like unless you do an evict.
I see.
We're basically only ever appending to those indexes.
I see. That makes sense. Thanks.
Or not even appending, just inserting into the key space.
Yeah, that makes sense.
Cool. All right. So next, I want to tell you a little bit about the justification for why we built a query planner in the first place, and what problem it solves fundamentally that is interesting in its own right, but is also relevant to how to make a cool Datalog closure engine. Yeah, what we're looking at here is like a screenshot from a thesis written a couple of years ago now. Theses are great because they always go into like from first principles, like this is the problem space, and these are the approaches that have been tried anyway. So this overview I thought was actually really, really nice and concise. And anyway, he has an example of what's called a triangle query, which is like the most basic cycle that you can get in a graph, or like a set of graph data. And this problem is essentially not intractable, but it's just a difficult problem to solve for traditional relational databases because they rely on like snowflake and star joins, which are ultimately like binary joins. They say like for these two tables, I'm going to construct a join of the entire intermediary result set before then like calculating the subsequent parts of the query. And as your cycles or the shapes that are cyclical in some way grow bigger and are more complex, this just becomes an intractable problem. This is the reason why Neo4j exists. It's because, for certain shapes of query, like relational database just doesn't work. But this property actually applies to this sort of hash join execution model, let's say DataScript has, where you take like the first clause, and then you take the second clause, and then you do a hash join, and then you do a hash join between those two and the third one, and then you do a hash join between those three and the fourth one, and it just gets like a bigger and bigger intermediate result set. And it works, but it uses a lot of memory in the process, and ultimately delivers the results all in one go. So there's a whole sort of field of query planning around this idea of worst case optimal joins, where they say, well, let's try and rethink that and do this sort of incremental search through the data. So this example of a triangle, you can see here like the big O notation complexity of doing that in a hash join approach is very poor, because you do sort of the first one and then you have to keep combining it. And this is just for the thing with 3 things. Imagine it with 5 of them where they're all connected. That's like 10 different hash joins. You're just joining over the same data the whole time. So this idea of having like a foreign key to foreign key on an edge relationship is problematic. And so these algorithms, this class of algorithms, identified like 7 or 8 years ago for the first time, tried to solve this by sort of proving that there's a way to do this to solve these queries in a way that's it's reasonably optimal. It's not always going to be the best way to query through the data, but it will always be guaranteed to terminate in a reasonable time. So this idea of variable at a time approach, this is what Crux takes to heart, and it says, well, let's not execute the query clause by clause. Let's build up this graph of the query, and let's build this like tree of iterators, and then pull out lazily everything from the indexes I need to answer each stage of the query. So to sort of reify this a bit, I'll go into a demo. Actually, I'll just pause for a second if someone wants to ask something. And I need to figure out how to share Emacs. Stop sharing.
You might need to, yeah, stop sharing, and then you can reshare either a different window or just your entire desktop.
I'm just going to kill my web browser as well. I think it's stealing all my RAM. All right. So I assume everyone can see. So I wanted to just quickly cover the Crux API before I get into the triangle join stuff. Yeah, essentially the Crux API looks like this. You call start node with an empty map if you want an in-memory node. So there's no transaction log. There is no document store beyond what you keep in memory. So you will lose everything if you lose the reference. Here we can see we're going to put a document. So we specify the transaction, and then it's just a Clojure map with an ID, and everything else is fairly arbitrary. As I said, you have to have keywords here. It doesn't support maps as keys. Although that did originally work, and I found out that worked, and that quickly got fixed. So, but anyway, it's still like a very sort of flexible thing, and it can be very deeply nested. Yeah, you can store byte arrays. So, if I run this here, like, yeah, you see, I'm starting a node. I'm awaiting the transaction. As I said, it's asynchronous, and then querying out the thing, and it's exactly the same as what I put in, and I didn't have to specify any schema up front, which is nice. It's very nice when you're developing. Usually you do want to add specs or whatever to your layer above Crux to keep sane. But it does allow you to move quite fast. I've already mentioned yet, so this put is literally added to the transaction log, but this thing then becomes a hash. So we store like the ID, we store a hash of this, and then we store the hash of the entire map. And then we put this map into the document store against the hash of the ID. And that's, yeah, and that's for eviction. And yeah, here's an example of just querying using hash comparison. So like we haven't declared anywhere that attributes are, is of type ref. You can just run this and navigate the relationship from foo to bar to baz in a very dynamic way. So the problem of a triangle query, I've got it here represented in Datalog. I've got a couple of other utility functions. So I have this idea of a haystack, which allows me to just create a bunch of random, not quite triangles. So yeah, this create docs function either returns something that is a triangle if the haystack is false, and it's not. Anyway, and the reason I have these construction functions is because I have this running in both DataScript and Crux, like the same entities or documents going in, but also the same query. So like I can just run this, define my shape query, and then execute my shapes, like insert them. So I can insert 200, I could insert 2000. Takes a moment to do it. And then you can see it's in there. We've got estimated number of keys. What is it? 64,000 keys in the key value store. So of course, as I said, that's across the entire key space. So that, that's probably, it's probably about right for 2,000 documents to 64,000 keys. Because each one has quite a few things. Anyway, what's interesting, as I said, is that in this query, like Crux will ignore the ordering of like, does this clause go before this other one? Whereas DataScript won't. Now, but this query itself is like so simple that actually it doesn't matter if you reorder that, like DataScript wouldn't execute any faster.
Hey, Jeremy,
Hey,
did you guys have a design reason for doing that? On your where clause, your constraint processing?
as in like a business reason, or just what do you mean?
Well, like an internal, like either architecture or yeah, business, or like, did you have any reason, I guess?
I think we looked at the state of the art for implementing a Datalog engine, and it wasn't hash joins. I mean, that was our conclusion, I think.
Okay.
Like, I mean, I've been using DataScript since 2014, and I've got a slide later. Like Hakan, who was sort of one of the lead engineers behind Crux, he had played with DataScript quite extensively as well. So we were very familiar with how that worked. But yeah, I think this realization that we could solve like multiple disjoint problems with one project, one initiative, Crux, was just a fortune. Like we didn't go out our way to try and solve this problem. It just seemed like the easiest way to get from point A to point B.
Yeah. Do you have like performance data on your constraint processing, like say Crux compared to either maybe also Datomic, and then maybe compared to a relational, and then maybe some other triplet store?
So we actually benchmark against like nightly. We benchmark against Neo4j and RDF4j, which are obviously graph stores. Like they actually have like some constraint processing element to them.
Isn't Neo4j like, so this is where I don't have hands-on experience with it, but as far as I know, it's a property graph database, right? And like this, essentially a Datalog database is a triplet sphere. It's node edge node, right? And so isn't there like architecturally or structurally, isn't there a difference in like fundamentally how you might go about processing your constraints and or traversing the data store itself?
Yeah, so the big difference, I mean, I think a triple store and a Datom and Neo4j are like further apart than Crux and Neo4j. I think Crux is actually a lot closer to Neo4j than you might think at first glance. The big difference is that Crux doesn't have properties on an edge. So we have this attribute, but we can't attach properties to it. That said, you can sort of treat this so that's a bad example because that's a query rather than data. But like here, where we have type A, we could refer to this combination of this ID plus this attribute plus this value, and we can refer to that as its own document ID. We can use a map ID or serialize into a string or whatever, and still refer or attach information to that edge. So there are ways of representing it. But yeah, essentially Neo4j or other like Redis or something called Redis graph, where they use like this really condensed like matrix storage and processing thing for graphs, which is like completely different to the index structure in Neo4j, which uses like memory mapped pointers, which again is completely different to how Crux resolves things with RocksDB and the LSM tree approach.
Cool, thank you. I'll check that out.
Yeah, it's a really interesting space. But yeah, we took a set of benchmarks from the RDF world and ingested them into Neo and Crux and others to run these nightly benchmarks. And that's how we sanity check how good the constraint model is. I mean, it's not, Neo4j has been going for like almost 20 years or something. It's quite an old or established, highly tested and tuned engine. So, considering the level of investment, we're definitely not far off in terms of performance, but also we're paying this bitemporal tax because, of course, all these other stores don't store history, let alone two forms of history. So, every time you make a query in Crux is like a marginal overhead to check the version that you're querying against. But we think that's a worthwhile trade-off. Cool. So the thing I was talking about, yeah, was like, I have this query and I can run it in Crux and in DataScript. So right now, well, okay, so I'll tell you what I found, right? So I have this triangle query, and actually DataScript's performance against the triangle query is actually really good. It still has this issue of like, it uses a lot of memory, because in order to, like, if I bump this number, instead of it being like 200 things in the haystack, if I make that like 200,000, like DataScript will use up gigabytes of memory trying to solve this query, whereas Crux is much leaner and can do it without blowing the heap at some point. But DataScript still does that triangle query actually slightly faster than Crux. Again, this is in memory, and so it's not like a apples to apples comparison. Also, DataScript is, of course, not durable. But if you extend it to like a bigger cycle, where you've clearly got a lot more going on in the query, and this is contrived, and like, is an example of something which is more theoretical than I expect most of your people here's queries to look like. It still does represent something which, if you've got several rules going on and a whole bunch of other predicates and stuff, like the fact that it reorders and manages to get it right and make it fast is quite impressive. But this query is so large actually that DataScript really struggles with it. And yeah, it's like, I mean, on the sample I have of, I think it was like 20,000 documents, like DataScript's consistently taking twice as long to churn through it than Crux. Bearing in mind, Crux has disadvantages in that it has these extra indexes it has to hop through. That's quite a visceral way to understand the difference. And another thing that Crux can show is this ability to run a query. What's going on here? Sorry, I was expecting some times to show. Is it showing there? Yeah, we have like shared caching. So when you use OpenDB, we're like reusing the caching between the queries. So you'll find your query speed increases if you use OpenDB. I mentioned OpenQ as well. So if we just want to get the first of these triangles that we find in the haystack, we can just get the first, and then it'll stop the query. So that's a powerful operation as well. So I did want to have like some nice graphs with like a profiler showing memory usage as well, but time ran out. But yeah, I think this is kind of interesting, and I maybe inspires other people to be interested. I'm happy to post this up to GitHub and we can discuss. Otherwise, anyway, I'll move back on with the talk unless someone wants to see it running. Oh, that was that. There you go. DataScript returning the same results in 40 milliseconds. Well, that's a different query. But anyway, yeah, that was for the triangle join. Okay, so I will go back to the presentation. If I can find it. Cool. So yeah, those cyclic queries, like why are they interesting? Well, yeah, in an application, as I say, like, you're not going to always come up against these cyclic graph problems, but when you do, you're going to want a tool that can handle it. But they're very useful in like recommendation systems or detecting bank frauds. Like this bank fraud example, it's quite common. Like this is actually from a Neo4j white paper where they discuss, having if money moves in circles, then it's usually an indicator of fraud. And like Twitter's been writing about this stuff for years about how it's detecting cycles is like the core of their recommendation engine. And maybe Jacob knows about this stuff as well. It's an interesting overlap. So anyway, that's what the engine is good at. Of course, yeah, doing regular Datalog queries is fine too. So I wanted to just to sort of step back and review like the wider picture, because as I said earlier, like I know like Christian's on and Paula and people that work on these other engines, and like I've met Nikita a few times, and I have a lot of respect for DataScript and things. So I just want to sort of review the terrain. But I wanted to point to this because this is like, I was shocked when I saw this because I thought I knew everything there was to know about DataScript at the time. And Håkan was like, oh yeah, I built a DataScript durable thing like however many years ago. And it's actually really minimal and uses MapDB, and maybe it was never used and it's really slow. I never actually tested it, but the code looked pretty neat. But the point was Håkan's been in this space for a long time. And nowadays, like Eva was released, when was that, like a year and a half ago, and that's not really gone anywhere. But nowadays we have this plethora of like Datalog Clojure things. And so this matrix, I'll caveat already at the bottom, it says this is not exhaustive. There definitely are things that probably should be on here that aren't. And sorry if I've gone into various projects and misread completely what the documentation says. But I've tried to like get an overview just for my own sanity, so that if someone asks me, I'm like, I can look at something. And again, I'd be happy to push this somewhere. But yeah, this breaks down, I think, the differences between the things that are available. And I think like all of this is, it's a point in time representation of the landscape. It's not by any means going to be relevant in 12 months or 24 months. And like I'm here talking to a Clojure audience, but reality is like, I would say, let's say 60% of our enterprise audience for this is like just Java users, or they're using Kotlin or something like, and that in a way is our priority for Crux. It's like we'd like to be good Clojure citizens, but we're never going to be able to build Crux to be the best Clojure database without some serious non-Clojure users as well. So this grid is a bit of an eye chart. I will run through some interesting ones. I guess at the top you can see that DataScript is the only thing that doesn't offer durable storage. Dataevelyn doesn't have transaction time. It's a sort of, I don't know. Like when I think of what a Clojure database should be, it should always be immutable. But anyway, you can always model immutability in the application, and you've got the single writer thing, so you can always recover that. And then the big thing where Crux differs to everything else is that we don't have this explicit schema, which means you have to think more as the application author to make sure you don't paint yourself into the corner. But generally people seem quite happy with that. And then we've made a trade-off quite early on in the design to sort of not think in terms of datums, and that's because if you intersect datums and bitemporality, things get very hairy for very little benefit. And so that's like a technical constraint, but also that the reality is most business systems interact via JSON, and that's just documents. So it seemed to be a more natural fit for, again, our like main audience outside of the Clojureverse, which actually see datums as alien. So that's why we've built it that way. So I'm not going to go through all of these. I've already covered most things. Pull syntax is interesting. I want to give a shout out to the Sami stuff, like on transitive edges and paths, because the Sami's added syntax to represent these like high level graph constructs in the Datalog language. So it's sort of an extension to the Datalog Eden, and some really cool ideas in there, which we've not thought to start tackling yet. And I also think composite tuples is a really nice feature, which is sort of still a missing story, I think, in Crux in terms of how to have these like secondary indexes, because that's kind of what they are, or computed indexes. So yeah, I'm not in charge of the roadmap as such, so I can't push that ahead, but that would be another feature I think people might miss if they're looking at Crux. And there was something I was thinking that I'd missed on this, but I didn't make a note. So anyway, this is like the functional capabilities, and then I did like another thing which is non-functional, and it's is getting Crux running a browser browser ClojureScript runtime like a goal. It's really not for Crux. Like, it would be nice. I think everyone on the team would like if it just worked, but we are working, within the constraints of the JVM and off-heap memory, and JNR bindings against native compiled things. It's like a completely different problem space, which would be nice to tackle eventually. I think there is some possibility to wrap data scripts such that it looks and feels like Crux. I have gone down that route once or twice just to try and get back this idea that you could sync between the server and the client. But yeah, I mean, that's a whole different kettle of fish. In fact, I mentioned my interest in data script, like before I got involved in Crux. It was like all about, let's just stick everything on the front end as much state as possible. Whereas now I'm like, let's just make HTML static and be happy. But anyway, that's my own personal journey. Graal is an interesting topic as well, because we do actually have a Graal build for Crux that was working as of 12 months ago, but it never made it into CI, so now it's broken. So it's potentially only one spare weekend away from being resurrected. Because I know people have been excited recently about Data 11 having Babashka support. Something else we've never really talked about much because it's not quite finished, but we would like to have like a proper song and dance about at some point, is the UI console we have built. So it has a few things missing, which I think are key. But essentially, when you spin up a Crux server, you go to port 3000, and you get a UI. If you take the same thing that you use for curl and you open that URL in the browser, it will just load this UI at the same endpoint. Yeah, I'd be happy to share this or like maybe push this up to GitHub or something. If people want to have this as a canonical resource, I'd be really happy to have feedback as well and make this less obviously biased in favor of Crux. And I really just do want to have like one place that avoids everyone having to do what I've had to do, which is like keep a mental model of all of this stuff in my head for however long I've been thinking about it. Okay, doke. I just want to mention the roadmap priorities. So this was actually covered quite nicely in our reclosure video we did in December, where Håkan talked about these things for a few minutes. So this is really what we're looking at over the next 6 to 9 months. And if I was to summarize it in a short sentence, I'd say like making Crux scale to the next level. So, rather than trying to run everything on one node and stick everything in a sorted key value space, like how would it look if we made it using faster primitives and sort of could migrate the existing query engine over to using like Apache Arrow files underneath. So that's the kind of trajectory we're working towards. And then these like advanced temporality use cases, which people who try to use Crux's valid time to do weird and wacky things will quickly run into. How do I know when something was true? Like if you don't have an idea of what you're looking for, the temporal indexes we have today like don't help you that much. You have to do a lot of scanning. But we know that there are possible ways to implement these temporal range queries and temporal joins, which we could then tie into the Datalog itself. So that's another avenue of thought. So that was everything I wanted to cover. I guess it's over to everyone else for Q&A. I'd be happy to talk about pretty much anything or go back to certain slides and look at whatever you like. Thank you. Or if Brian's there, you can tell me what normally happens at this point.
Hey, yeah. Normally we just do now kind of a Q&A and maybe just go through any, anything anyone else, either if they have announcements or anything that they want to mention. That was a great presentation, man. Thank you very much. I got a lot out of it. I've looked at Crux, you know, kind of just sort of had other things on the docket as far as, you know, mainline development tasks. But it's kind of like, wow, this would be great to use, you know, in a lot of different ways on our application. And so it's great having a, you know, a firsthand overview like this.
Cool, that's good to hear. Thank you. Yeah, I mean, all these things, you know, it requires a lot of good fortune, doesn't it, to be like, oh, I'm at the start of a project which could use exactly this technology. But hopefully we'll be, you know, there when you need us. And yeah, we're not going to stop making progress in the meantime.
I'm curious about the SQL side of things. You said that Crux is kind of the only one of these DBs that has a SQL API. How much SQL does it support?
So how much SQL? So if you, we have enough SQL to run the TPCH tests.
Okay.
So that's a reasonable amount. Like they're used for benchmarking. It's like an analytical benchmark. So yeah, it runs on DB2 and Oracle and Postgres or whatever. So that's a fair amount of syntax it covers. We haven't implemented everything natively in Datalog. Some stuff we lean on the calcite implementation of, but certainly joins all get pushed down into Datalog joins. And I think like filtering and leaf values and things like that as well.
Wow, that makes me absolutely fascinated. I will definitely have to start playing with Crux. Thank you.
No, cool. Yeah, it was a really interesting insight actually. Like it was I've never done like big Java development, so it was really fascinating to watch like how do we glue Crux to this huge awesome Java behemoth of a project which is calcite. And it's a really interesting project itself. Like it has its own query planner, and it even has like a materialized view engine which we could potentially use at some point. So we're really just waiting for use cases to drive requirements there.
If you try to integrate Crux with to be invoked from other programming languages other than Clojure, you should invoke Crux from by means of the HTTP API.
Generally, yes. I certainly from Kotlin or Java or Scala, even probably any JVM language, you should have a good time now with we added some new typed interfaces recently. But in general, yeah, we have JSON over HTTP as the default polyglot solution, and like a Swagger endpoint, which maybe you could generate some client libraries, although we've not tried that yet. The only caveat to not supporting JSON everywhere is the Eden query. Like that's the only thing that doesn't, that requires someone to be like, I'm not just writing regular JSON.
Okay.
What language are you thinking of in particular?
For instance, Go.
Go, okay.
I'm using that feature in my applications too, because I have, it's most of the stuff I work on is a Clojure web app, but there's a 300-line Python file where it does some data science stuff. And so to get at the data, I just use the HTTP server from Python, and it works really nice. What I've been, because there's an Eden library in Python you could use to construct the queries, but I've found it's easy enough to just write it out in a string. And sometimes if I need to put in a parameter, I'll just do a string concatenation.
That's a good data point. Yeah, I've tried to tackle this problem like myself, like how to represent the data log with JSON. I don't think it's that hard to do, but to make sure it covers all cases and that everyone's happy. Like you don't want to put something out there that's wrong in any way, otherwise you get very it's very hard to wind back from those sorts of things. Cool. What else has been talked about?
I have one question. This is kind of partially perhaps just a marketing thing, but do you have any plans for when Crux will no longer be in beta? Like, are there any specific requirements, or is it just kind of, oh, we'll see when it feels like it's time to take it off?
Yeah, it's a bit of a curse, isn't it? This is Clojure pattern of keeping everything in alpha or beta for too long. We don't have a concrete milestone, but because of the nature of the because of the nature of the model, like we've never broken the transaction log. Anything you've written like 2 years ago onto the Crux transaction log and into the document store, like it will still work today. And the point at which you change that, it will stop being 1.x, it will be 2.x. And there's no clear candidate for why we would switch to 2.x yet. But if we did have a good reason to do that, then maybe that would be the point at which we lose the beta. I guess the other thing is API stability, and you don't have to keep rewriting your application if we tweak the async semantic of submit tx or whatever it is. We want to keep that stable, but it's still a work in progress, I think it's fair to say. But look at the commit logs. These things have been pretty stable, and very few people have had like problems migrating, at least. Cool.
I have another question if no one else wants to jump in with something first. I'll just go ahead, I guess. So have you considered since you have indexes that are keeping track of the valid time of entities that get transacted, right? Would it be a possibility to expose that more to Datalog queries? So for example, like if you're just using a regular database value, not using as of or anything, but then say I wanted a query for documents that were created at a certain date, but I didn't want to bother with like adding my own explicit timestamp attribute to it. Does that make sense?
Yeah, it does. Yeah, we've not done that mainly because it's not been like low-hanging fruit to do that. But yeah, like having EAV, VT, TT in the triple clauses, extending them to be quintuples or whatever, that would work. That would be possible. You can work around it now just by creating a custom predicate, which is like get transaction time, and then you pipe the entity into that to pull it out. And if you need help writing that, I can help you. But yeah, it comes back to, again, like the design work to make sure you get it right, isn't worth the, well, we just limited resource, limited time to think about all these things. And I guess other things have taken priority. But we were actually only talking about it yesterday. We're working on a project currently. I can't say too much, but it does involve temporal queries, and that is a bugbear. And like we can't express this particular history query as like one query. It'd be really nice to do it as one query, but right now we have to use OpenDB and fire off a few different queries. And the performance is almost the same as it would be. It probably is exactly the same as it would be as if it was one Datalog query, because ultimately it all gets executed in the same like outer query loop, because you've got the shared caching between the queries.
Makes sense. Thanks.
Yeah. Cool. All right. Anyone else?
I just want to say thank you. Very enlightening.
That's a pleasure. Thank you very much for inviting me. It's nice to speak to this meetup. I've definitely said I would join several of these meetups now, but they're always sort of far too late for me to actually be up. Like I'm not as young as I used to be. I keep going to bed too early. But I hopefully will attend another one soon.
Yeah, thank you very much, Jeremy. I apologize. I'm a little bit subdued today. I drove from Seattle to Utah last night in a snowstorm. It took me about 13 hours. So sorry I'm a little bit quiet today, but no, man, thank you so much for that presentation. That was really great.
Let's get a round of applause.
Yeah, thank you.
Thanks for joining. And
Cool,
yeah, if
well-
anyone wants to ask any more questions, I'm always around on Slack and stuff. Just ping me.
Awesome.
Will do.
Oh, sorry, go ahead.
No, I just want to say I definitely have lots of questions, but I don't really want to bother everybody with them.
Well, I'm happy to stick around for a bit. I'm not nowhere to rush, but bed. But it's fine.
No, it's not something that I want to do right now. Thank you, though.
Jeremy, I guess so if someone were just to kind of start playing around with Crux, do you guys have like a kind of a chapter 1, chapter 2, chapter 3 sort of roadmap for kind of getting your feet wet with it, and then just the executing queries and against data structures that kind of show off its features?
Yeah, well, we have this space tutorial, which is yeah, I guess it must be 18 months old now, but I mean it's still up to date, and we can make sure it is tested. So there's that. It's not like super advanced. I think the reality is like so much you can do with Crux, which you could spend forever writing. You probably write a book on it. So there's a lot of good stuff in the Slack archives and the Zulip archives, which maybe we should pull out and sort of make more concrete and sort of walk people through it. So yeah, right now the tutorial is the best resource for that. But I think if you have like a particular thing you're trying to build, like it'll be quite clear, like the order in which you need to learn things. And as long as you give the docs like a once over before you start, you probably won't make really many like modeling mistakes, just because the model is so simple. Yeah. I mean, if you had an example of something you think, like someone posted what was it? Some JavaScript tutorial, but like it was just a really, really slick tutorial. I'll close the browser. It was a really slick tutorial interface, where you have like the steps and you press next, and then you press the button to fill in the blank if you can't be bothered to work out the answer yourself, and it has the stuff coming from the doc strings and things. Like, yeah, we'll probably be doing something like that this year as well, just to ease the onboarding experience.
Sweet.
Yes, it was a Svelte tutorial. That's right.
Cool. Well, I think if nobody has anything to add, should we go ahead and call it?
Sounds good. Thanks so
Going
much,
quiet?
Jeremy.
Man, thank you so much, Jeremy. Thank you for staying up late with us and getting us introduced to Crux. I hope that it'll produce at least one or several future Cruxers. So I think a lot of people were interested, and we'll put this also up on YouTube, so it'll be searchable and available indefinitely. I'll send you a link once it's up.
Cool, thanks. I'm just looking at the chat as well. I hadn't seen this. I don't know, can we take an export of this? Yeah, send file, save chat, I'll do it. Cool.
Yeah, cool.
Sorry if there's a question there I haven't responded to. I'll give it all a read through. Yeah. Nice,
I think
nice
your
evening.
colleague Stephen was going through and handling questions as they were coming in.
Top man, thank you. Cool.
Cool.
Enjoy the rest of your evening.
All right, guys. Have a great
Have a
evening.
good night, everyone.
Thanks.
Everyone. Bye.
Okay.
Thanks.
Bye.
Thank
See
you
you
very
guys.
much.
Bye.
Bye-bye.